even in the structure questions, you may find this that finding the acceleration due to gravity, or write a short experiment about the acceleration due to gravity, how it can be, how we can find. So we can use the equations of the motion to find the acceleration due to gravity. Different equations of the motions can be used depending on the parameters which we are measuring to for that specific experiment. Example, in this experiment, we have an electromagnet which is attached to an electric circuit, and there's a ball bearing attached to this electromagnet, because when there's a current, the electromagnet, it's behave like a magnet, so it attract this steel ball, or you can say iron ball. You can also take that. Now, what happened? The moment we tap this button here, what will happen? It will demagnetize the electromagnet. So as it demagnetizes the electromagnet, the timer will start. And when this ball hit the trapdoor, this will open. As a result, when the trapdoor opens, the timer will stop. So the moment the electromagnet demagnetized, the timer start, and the moment the ball bearing hit the trapdoor, the timer will stop. So actually, that is the time taken by the ball to fall this distance. So we got the time. Why it is more accurate compared to a stopwatch? Because if we are using a stopwatch, then there will be a reaction time which makes it difficult for, because the distance is so short that the reaction time will leads to a greater uncertainty in the result. That's why we are using a digital timer here. So the moment we switch off the electromagnet, the timer starts, and when the ball bearing hits the trapdoor, the timer will stop. By using a meter rule or a meter scale, we measure this height, and using a timer, we record this time interval. What about the initial velocity of this object? The initial velocity of this object is 0. So what are the parameters we are measuring for this experiment? We are measuring the initial velocity, which like it is 0. So we know that the initial velocity is 0. We are measuring the height, or we can also say the displacement, and we recorded the time. So which equation of the motion I can use, because I want to work out the acceleration, and that acceleration will be same as due to gravity, because our assumption is that there is no air resistance. Practically, there will be air resistance, but for a short distance, we can ignore a air resistance. And how we can minimize the effect of the air resistance? By using a ball bearing, which is a streamline object, like it has a least air resistance on it. Plus, we prefer to use a heavy ball bearing as compared to a lighter, because a heavy ball bearing, air resistance will oppose the motion, but it won't balance with the weight easily as compared to a lighter ball bearing. And we try to keep a minimum distance between the position of the ball, initial position of the ball bearing, and the trapdoors, because if you drop from a greater height, then air resistance will have a greater effect on that. So if you want to use, like example, if I say I want to work out the acceleration, can I use this equation? V is equals to u plus at. Can I use this? I want acceleration due to gravity. But the problem, we have u, we have t, but we don't have v. So it means I cannot use this equation. If I write the second equation, s is equals to u plus v divided by 2 multiplied by t. So if we are trying to use this equation, the second equation, we have u, but we don't have v, we have t, and we have the displacement. But the thing is, our main subject is not the final velocity. That's why we cannot use this equation. Yeah, acceleration due to gravity is 9.8, as it has no air resistance. But practical, like right now we are doing practically how we can find or show that the acceleration due to gravity is 9.8. So this is an experiment to show that acceleration due to gravity is 9.8. So we cannot use this equation. What about the third equation? So we have s is equals to ut plus half at square. So I have u, I have t, I have this displacement, so I can use this equation. So if we rearrange this equation, the s is the height from which we drop, u is 0, plus half. Acceleration is due to gravity. Like we know it's 9.8, but we want to find it practically. And then t square. So when this equation is simplified, it will be h is equals to half gt square. Now, when experiment is done, we always repeat the experiment to identify the anomalous results and type of the error which we have in our procedure. Like it might be a systematic or a random error. So what we do, we repeat this experiment for different heights. Like first we did, for example, 20 centimeter, then 30, then 40 and 50 and so on. So when we repeat the experiment, we prefer to plot a graph. How you will know which graph is suitable here. So whenever you want to identify which graph you will plot, so you will always compare with the equation of a straight line. Like this is our equation that h is equals to half gt square. If I compare this equation with this equation of a straight line, which is y is equals to mx plus c. So y is equals to mx plus c, what does it mean? On y-axis, if I plot the height, on y-axis, if I plot the height, on x-axis, if I plot the t square, because we are measuring the height and the time. So on x-axis, if I plot the t square, there is no y-intercept because nothing is added here. So y-intercept is 0. It means this graph will start from origin. So what will be the gradient of this graph? The gradient of this graph will be equals to half g, or if I need g, so the gradient multiplied by 2, I will get the value for g. And what will be the shape of this graph? Because this graph is half g, the gradient is equals to half g. It means half is constant, gravity is also constant. Whenever the graph is having a constant gradient, it means it should be a straight line. So the graph between the h and the t square, it will be a straight line which will start from origin. So when what we will do, we will change the height and we'll have a different time intervals. Then we'll plot the result for h and t square, and we'll draw a line of a best fit, and finding the gradient of that line, the first point on x-axis, that will be x1. The second point on x-axis, that will be x2. The first point on y-axis will be y1, and the second point will be y2. So when we work out the gradient, y2 minus y1 over x2 minus x1, after getting the gradient, it will be multiplied by 2 to get the value for g. And it should be in the range of 9.8. So g will be, in this case, g will be equals to twice of the gradient. And why it is a straight line? Because as you can see, the gradient is equals to 1 by 2g. 1 by 2 is a constant. Like it's a fixed value, 0.5. G is also a constant. Acceleration due to gravity is a constant. So means the gradient of this graph will be a constant value. Whenever the gradient of a graph is a constant, it means it must be a straight line. And how we identify it to start from origin? How we identify that should start from origin? Because the y-intercept of this graph is 0. Is it clear practically how we can work out the acceleration due to gravity?
Yes.
Anyone having a doubt or a question till this point? This is one of the method. Same way, this experiment can be done in other ways. Well, like instead of using this timer and the electromagnet, we can also use like stroboscopic quick light is can be used, as well as we can also use a digital camera. And we photograph this motion of this object. For example, we can use a video camera here, digital camera. So these are the position of this object at different intervals. Okay. So what will happen using the digital camera? It can be like we can use the pictures as well, because for pictures, in case of pictures, it will be frames per second. Like every camera is having a specific value of the pictures it can take every second. So using the frame per second, we can work out the time. Or if we are playing a video, we can identify like the position and the time interval of the video. The moment we drop, we start the video, and we record the motion. So using a digital camera, we got the time. Okay. And we place it beside the meter rule. A meter rule is placed, so we'll know the position. Using this, we can work out the distance. So we have the distance and the time, and we what is the initial speed as a ball bearing is dropped. So the ball bearing is dropped, the initial speed is 0. So initial speed is 0. We can also use the same formula. S is equals to ut plus half at square. So initial velocity is 0. S is equals to h. U is 0. So this will become half gt square. And again, we plot a graph. When we compare with the equation of a straight line, we'll compare by using a graph. Y is equals to mx plus c. On y-axis, if we have h. On x-axis, if we have t square, again, our gradient will be half g, or twice the gradient will be equals to value for g. So using this, we can also work out the same value. There's also another way to work out the acceleration due to gravity is by using the final speed. The frame per second changes for every camera, because high resolution cameras have more frames per second as compared to low resolution. So example, if you want to determine the acceleration of a free fall, another method we can also use. Say an object is there and we are using a light gauge. Okay. We can use a light gauge. So here we have a light gauge. Light gauge can be used to determine the time interval. Now we drop an object from a cylindrical object is there, we drop from certain height. So what will the starting speed? The starting speed will be 0 because it is dropped from certain height. So u is equals to 0 meter per second. Using a micrometer or a vernier caliper, we measure the length of this object. Now, and the position we drop till the light gate, we measure this height. Now what will happen when we drop this object? As the object will fall, why we took a cylindrical tube here? So it is just minimizing the effect of the surrounding air. That's why it is used in a cylindrical tube. So when we drop this object, the object will move. As the object will move, it will interrupt the light or interrupt the light from these light gates. So how long it will take to interrupt this light gate? So we got the time because these light gates are connected to the data logger. Like it is connected to data logger, then to a computer CPU. So we got the time. So we drop an object from certain height, and when the object fall, it will interrupt the light gate. So the duration for which the object interrupt the light gate and the length of this object. So length of this object divided by the duration for which it interrupt the light gate, we get the final speed. That is speed at a specific point. So length of the object divided by the time interval for which it interrupt, because the length divided by time or distance divided by time will give us the speed. But what is this speed? This is the final speed of this object. Now, what we have u. We want to find a, the displacement and the final speed. So which equation we can use? If we try to use this equation like 2as equals v square minus u square. So I can substitute 2gh is equals to v square minus 0 square, or 2gh is equals to v square, or I can also write v square is equals to 2gh. Now when I compare with the equation of a straight line, which is y is equals to mx plus c. So on y-axis, if I plot v square, and on x-axis, if I plot the height here, what I will get, my gradient will be equals to 2g. Or gradient divided by 2, what we get the value for g. And it will be a straight line. Why it is a straight line? Because the y-intercept is 0. And why this? It will start from origin because the y-intercept is 0. And why it's a straight line? Because the gradient of this graph is a constant. Why v is equals to L over t? No, because we need the speed at a specific point. Whenever we need the specific point, if I use v is equals to h over t, then I should know this whole time interval. If I know the whole time interval and this distance, and I use the formula v is equals to h over t, I will get an average speed of this motion. But I don't need an average speed, I need an instantaneous speed. The term instantaneous speed means speed at a particular moment of a time. So to work out the instantaneous speed of an object, what we have to do, if an object is moving horizontally, so we should measure the length of the object and for how long it interrupts the light gate. That will give us the instantaneous speed of an object. If an object is going vertically downward, so we measure the length of this object, and for duration what it interrupts the light gate, that will give us the instantaneous speed of an object. So to get the instantaneous speed, it's the distance, the length of an object divided by the interruption of the light gate. So using this method, we can also work out the acceleration due to gravity. Is it clear, this one? Any doubt or a question in this experiment? Yeah, the light gate only gives the time for interruption. So when you have the light gates only give us for how long it interrupts the light gate. So when the object block the light, and then the moment objects come out, we got this time. The length of the object is known, so length divided by time, we get the speed at which the object interrupt the light gate, and using that speed, we work out the final speed of the object. That's the final speed of an object. If I can do this experiment by using the two light gates, if I use the two light gates, then I will not consider the initial velocity as 0, then it will have some value. But this is to make a simplified. That's why we are considering initial velocity will be 0. So how v is equals to, so for example, if I say this is a light gate and this is a beam of a light, an object is there having a length of say 2 meters. So when this object will move, it to interrupt, like how much distance it will cover to interrupt this light gate. So it will cover 2 meters and then interruption will be over. So the length, the distance covered by the object is always equals to length of an object. That's why we took the length. And the duration, like example, if this light get interrupted for like 0.5 seconds. So at what speed this object should interrupt the light gate for if it interrupted for 0.5 seconds. So we have the formula speed is distance divided by time. So what is the distance covered? The distance covered by the object is 2 meters when it was interrupting. And the duration what it interrupted, that is 0.5 second. So 2 divided by 0.5, so we got 4 meters per second. So this object must move with the speed of 4 meters per second if it want to interrupt the light gate for 0.5 seconds. That's how we got the speed. Is it clear? So light gates are used to work out the instantaneous speed of an object. Any doubt in this?
No doubt.
What about others?